Oxidation and reduction. They are part of the same process. One cannot proceed without another, but you need to be able to differentiate between the two. In oxidation, the loss of electrons, we would always observe increase in the oxidation state because the atom or ion is losing negatively charged particles. We will see that oxidation state is rising. In this example of oxidation of magnesium, magnesium is oxidized, and as a result of it, its oxidation state changes from 0 to positive 2. Reduction represents the gain of electrons, and gain of negatively charged particles would always lead to reduction, decrease of the oxidation state of atoms or ions, whatever is reduced. Over here, in reduction of oxygen, we see the oxidation state drop from 0 to negative 2. Okay, let's analyze this reaction over here in terms of oxidation and reduction. Let's figure out what has been oxidized and what has been reduced. First of all, we need to assign oxidation states for every single thing that we see in this reaction. Okay, we start with uncombined element of sodium and barium. Uncombined elements have oxidation state of 0. While barium over here, element for group number 2, so its charge and its oxidation state is positive 2. This chloride ion is supposed to have a charge of negative 1. Sodium also predictable in terms of oxidation state, and we can calculate oxidation state for the chlorine to be a negative 1 over here. So now we can see the oxidation state of sodium is changing from 1 to 0. It went down. It means that the sodium was accepting electrons to go from positive 1 to 0. We have 2 sodium ions. Each accepts 1 electron, so total 2 electrons are accepted, and 2 atoms of sodium are formed. Where those 2 electrons are coming from? Those electrons are coming from barium. Our barium used to be an atom, but it decided to become an ion. It lost a couple electrons, which were very nicely picked up by sodium. So sodium has been reduced. Its oxidation state went down due to the fact that it accepted negatively charged electrons. And barium has been oxidized. Its oxidation state went up because it lost electrons, and oxidation state increased. And let's see what happened to chloride ion. It used to have a charge of negative 1. It still has a charge of negative 1. It means that actually nothing happened. Neither reduction nor oxidation was happening to the chloride ions. So it is a spectator ion that is not playing an important role in this reaction. So we can rewrite this equation into simplified form. Here it is. You can see that I dropped the chloride ion. Since chloride ion did not play any important role in the reduction or oxidation, I did not even wrote it in my simplified equation form. This is the most important species of this reaction because sodium is getting reduced and barium is getting oxidized. Let's do the same kind of analysis over here on this reaction. Let's analyze what has been reduced, what has been oxidized. We start by assigning the oxidation states to everything that we see in this reaction. Calcium and hydrogen are getting oxidation state of 0 as they are uncombined elements. Then we can deal with hydrogen and oxygen, and knowing that the oxidation of this compound is supposed to add up to 0, nitrogen comes out to be positive 1. Calcium over here has a charge of plus 2. And if we calculate our oxidation states correctly in this compound, nitrogen comes out to be positive 5, and oxygen, of course, negative 2. Now, let's see. Oxidation state of calcium changed. It went up, it increased. It means that calcium atom started to lose electrons. Okay, calcium turned itself into calcium ion. 2 electrons are lost, but they are not lost completely. They are actually going to join our hydrogen, which will be reduced by accepting these electrons and turning itself into the hydrogen atom. Calcium lost electrons. It had been oxidized. Its oxidation state increased. It went from 0 to positive 2. And hydrogen has been reduced. Its oxidation state went from positive 1 to 0. It accepted negatively charged electrons, and as a result, oxidation state dropped. But nothing really happened to the ion of nitrate that is part of this reaction, because it is another example of spectator ion. Neither nitrogen nor oxygen played an important role in this reaction, not in terms of oxidation and reduction. It is a spectator ion, and technically we can drop it out of the equation entirely, because what we're really interested in is oxidation and reduction of the equation. Here is my equation written in a simplified form. Technically, I have enough information over here for myself to figure out what has been oxidized and what has been reduced. Here is a typical question that asks you to identify what has been oxidized and reduced. To answer it, we need to assign oxidation numbers, oxidation states of these elements. Lead and cobalt get oxidation states of 0 as uncombined elements, and to analyze these ions, it's ionic compound of cobalt-2 chloride, so cobalt has a charge +2, and chloride as an ion always has a charge -1, so my lead is +2. Now let's see. The oxidation state of cobalt went up. It means that our cobalt is losing electrons. It is oxidized. So out of these possible answers, we're choosing between 1 and 2. Cobalt is oxidized. And let's see what has been reduced. Well, lead has a charge +2 over here, and then it has a 0. So our lead accepting electrons and dropping in charge. So cobalt is oxidized, and lead +2 has been reduced. Our answer is right here. Another example. Over here I am given simplified form of the equation, but that's quite enough to figure out what has been oxidized and what has been reduced, especially if I will assign my oxidation states for my uncombined elements of iodine and bromine. So I can see that iodine went from charge -1 to 0. It is increased in the oxidation state. Iodine has been oxidized. And bromide went from a 0 to a -1. It was accepting electron. It was its oxidation state went down. It was reduced. And its number went from a 0 to a -1. It went down. Here is our answer. Iodine -1 has been oxidized, and oxidation number went up. Okay, here it is. Which substance is oxidized? We know that oxidized substance is supposed to increase in the oxidation state. So let's assign oxidation states. We start with our uncombined elements. We continue with the rest of the things. And the clear-cut answer is zinc. Zinc increases. It is 0 initially, and it is +2. So the substance that oxidizes is supposed to increase in the oxidation number, and zinc would be our answer. Which species, meaning the parts of these reactions, undergo reduction? Well, to answer this question, we quickly assign the missing oxidation state of uncombined nickel, and we can see that the nickel goes from 0 to +2. This one is nickel is getting oxidized. So tin goes from +4 to +2. The number reduced, it goes down. So tin plus 4, this guy over here, undergoes reduction. To answer this question, which substance is oxidized, we need to see which substance increases in its oxidation number. So we start by assigning oxidation states. Uncombined elements, oxygen -2, hydrogen +1. Sodium already has a charge, and this is polyatomic ion. Overall charge is -1, hydrogen in it +1, and oxygen -2. Oxidation state of sodium is increasing from a 0 to +1, so sodium atom is getting oxidized. And we can see that hydrogen goes from +1 to a 0. So if there would be a question about what has been reduced, we would say that H plus 1 getting reduced. Okay, last practice question for this video. In this reaction, ions of potassium are reduced, oxidized, gain or lose electrons. So let's see. Let's quickly assign the oxidation states. So +1 for potassium, -1 for chloride, and here uncombined elements are 0. We can see that potassium goes from +1 to 0. So we can see that its oxidation state drops. It's been reduced. So K plus 1 is reduced and it is accepting electrons. The fact that this number went down is the result of potassium plus 1 accepting an electron.